edit distance. So in this first question which we are going to do today, we will be going ahead with 3 approaches: recursive and doing its memoization, and then after that bottom-up DP. Now comes the part that how we would be doing the recursive approach over this question. But before that, we need to understand about this edit distance question. So let me explain you this. So here comes the part. So now in this question, what we are doing is, here we are required to that we are given with 2 strings, word1 and word2. We are required to return the minimum number of operations required to convert word1 to word2. And how we can do this is, either we can insert a character, or we can delete a character, or we can replace a character. So this is the question given to us, and here this horse is given and the rows 2 words are given. So how we will be making this horse to the rows? Now comes the part that for making the same, we can do this thing, that replace H by R. So H would be replaced by R, so it becomes rows. And now we need to do is, we just need to remove R, the third R which is here, right? And then it will become rows, and now we need to remove E. So basically we took 3 operations for doing the same. And same comes the part for intention and execution, that some removal is done, insertion is done, and replacement is done. So while doing all these 3 operations here, and then these operations are done in manners that we are at minimum able to get this particular word. Means with minimum operations we are able to get the other word. That's the thing which we are doing. So here the constraints are that a word length 1 and a word length 2. Basically both of them are not more than 500, and word 1 and word 2 have only English lowercase letters. So this was all about the question which is given here. Now let us move ahead for the explanation part. So for recursive approach, how we are required to write a recursive solution, and for that we first need to check in a question only, as we are required to convert one string to other string, and we can do by 3 options only as per the question mentioned, that we can do insertion, we can do deletion, and we can do replace. And if you could recall in the last video of LCS, what 2 operations we were able to do? We can either insert or we can delete. But in this edit distance question, only one operation is there that is being added, and that is what it makes it somehow a bit different from our LCS question. So here, insertion and deletion is same as the LCS, but only replacement, we need to take care of that. So tweak in the LCS question to make it edit distance question. That is what has been done. Now comes the part that how we can go ahead with recursive solution. So for that, first we need to check according to question only that what things are there. So for checking that is when we can insert or delete or replace, on which condition we are required to do. See, if the word is same, right? If I take example, cat and cut. So here is we see this T is same, right? So as both of them are same, so we will enter this case 1. So case 1 says that if S1 of M is equals to S2 of M, then no changes are required, thus we need to move ahead. So accordingly we will code for this particular case. Now case 2 comes that we need to insert, replace or delete at only that moment when both of the characters are not matching. That is a scenario, because what we are required to do, that we need to change one word to other word, and when we are required to do the same, then surely there is some non-matching scenario. So for that particular purpose only we need to do some operation, and that's the thing which we are doing here. So further subcases which are being generated here is that either we can insert a character in S1, or we can delete a character from S1, or we can replace a character in S1 from a character in S2. So how we need to do this programmatically see, as the S1 is having the character count as n and the S2 is having the character count as m. So what we would be doing is when we need to insert something, say if we take this example only, cat, and let us say take example of Q. So now for making T and E, both of them are unequal, right? So for making cat into cute, what we are required to do? We are required to insert something here, right? When T is here and this is here. If we choose this particular operation, that is insertion. So our T would be at this particular, means n pointer would be at this particular position only, and we would be adding E here. That's why n is basically here only, but we are moving ahead in m. So we will move here, means we will move at T. Now we will check that T and T both are same. So this case 1 would be considered, right? So then again we'll ignore both of them, but no operation is counted. Till now only one operation is being counted. Now we take as A and U. If we go ahead with insertion, right, then again we will move this to this particular, not this one, but we'll move this to this particular, and we will be adding U here. That would be the scenario. So when we add U here, basically here U would be added, and this particular A which was there, that will remain at this particular point only. Or if we choose to delete, then in that scenario, what would be the case? That this A will be moved to here, that is we directly excluded this A, and this pointer at U will remain here only. So now this particular word is somehow like this, means one operation is again done, and this word becomes CTE, and the other word which is down there, it becomes CTE. That is the thing it will become, because this will be same, this cute only, and this CTE will become, because T just skipped the A. This is a scenario which we will be doing in delete. But if we don't do this particular, and if we do replacement of the word, then how this particular would be like? Then till now we have this TE and TE, right? Now A and U was the point. So if we replace A and U, then we will be skipping both of them, and then our new word would be something like this. And the other one would be also, because we skip both A and U. So here, that's why we are doing n-1 and m-1. And in deletion, how we are doing? That we are skipping the first one, that is this one, and that other word having the pointer at same position. And when we insert, then again we are adding some character just behind it. So that's why we are not skipping, and we are just staying at that particular character only at where we were staying previously. So that's how this will work in our program. Now comes the next part. This was about the cases which we are required to handle in our recurrence relation. Now comes the part that we are now knowing about the options, about the recurrence relation. Now comes the part for the base case. Because we would be traversing this whole length, if you can, now here I have explained you about the cases. So yeah, now it would be required to explain you that recursive tree which I just made. This is one of the examples that how things would be. But you can see that whenever we reach a particular blank, right, in that scenario, and even when one of them is blank and other one stays, so in that scenario, what is the operation which we can do? Either we can skip that, means delete it, means we can delete the other one. That simply means we can insert that into this. But here delete operation won't work, and replace operation, yeah, that will work here, because we would be skipping both of them. But the first one doesn't have anything, so how we can skip? So this all scenario picks up a base case here, that if n is less than 0 or m is less than 0, then we need to return +1 in that particular scenario at that moment only. So that's why here the base case simply becomes this one, that now we are not able to traverse our particular string, that is, it is now empty. So that's why at that moment only we will return +1. Why we are returning +1? Because when it becomes less than 0, that is now no index is there. So at that scenario, either we can insert or we can delete or we can replace. So that's why for that particular scenario we are giving 1 to that thing. So this is the thing which we will be doing there. So this was about recursive relation and base case and the options. Now comes the part that how we need to memorize it. So for memorization part, you can see that we are having two variable parts, that is n and m. So that simply reflects that we would be required with a two-dimensional data structure. And for that purpose only, when we require a two-dimensional data structure, so we are required to store our result, and for storing a result of our recursive calls in the same. So in that scenario only, we will be doing all the same. Because when we are going ahead with all the recursion part, then there would be a lot of subcases which will be repeating again and again, and that's why we need to memorize a solution. Because when there were a lot of solution, means basically there were 3 choices which we were having, and each choice was n plus m raised to power not this one. We were having 3 choices and each choice was having n plus m times of occurrence. That was the thing. So that's why the recursive time complexity became something like this, and the space complexity remains n plus m. But now comes the part, when it becomes a memoized solution, then in that scenario, the time complexity becomes order of n into m because of this 2D DS which we would be taking, and the space complexity, that also becomes n into m just because of this 2D DS only. So that was the scenario how we reduce the time complexity of exponential time to a we can't say it linear, but it is in square only. Means from exponential to square time complexity, we have changed the solution. So this was about the same. Now let me explain you about the bottom-up DP. So for bottom-up DP, if we convert our memorization part into a tabular form, how it would look like. So here the thing would be that we need to be concerned about these 3 operations only, right? Insertion, deletion and replacement. So for bottom-up DP, we need to take care about our base case, our state and our transition. So our state here would be in 2 variable parts only, that is one for the word 1 and another for the word 2, and because we need to require doing operation according to insertion, deletion and replacement according to both of the words, right? So that's why what we would be doing is we will be having a 2-dimensional data structure again here. So our state would be dp of ij, where I simply represent the pointer which is for the length of our word 1, and j simply represent the pointer for the word length of the word 2. And now comes the transition part. So here transition will take place according to 3 operations, that is insertion, deletion, replacement. And in that case also, when both of the words are equal, so in that case also there is the operation which we are required to do, but that operation would be counted as 0 only. So here we can add that, as it would be 0 plus 1 when both are same. Basically, I am adding up the transition which we are required to do. So when both are same, then in that case transition would be like this, that we are skipping both of the words because there is a match. But there would be 0 addition into the operation, because what we are required to do is that we are required to have number of operations. Now comes the part for insertion, deletion and replacement. Again for the same case, the way we were having for the memoization recursion part. So we are required to add up 1, 1, 1 at each of these cases. because all of this will contribute to one operation. So in the insertion scenario, here we are having TP of I, right? And j minus 1. That is because of the case which I explained above, that we are inserting one character to word 1. That's why it will remain at that position. But we will be skipping our present character of word 2. That's why we are making j minus 1. And same for the deletion, and then same explanation for the replacement. So that's why we are doing this. Now for a question, what we are required is that a question requires the minimum number of operations required, right? So that's why we will directly do minimum of these. So that will complete our question. Means doing this operation and finding out minimum out of these. So to sum up everything, what we are required to do is, in this DP, our base case, that would be simply if n is less than 0 or m is less than 0, then in that scenario we will be returning plus 1. That means when we will be coding, then in that scenario I'll explain you that how it will be. And the state would be TP of ij. And why TP of ij? Because we are required to change word 1 and word 2 both. And then now comes the part of transition. So for transition, if our S1 of I is equals to S2 of j, then in that scenario we will be directly returning, or here because it is TP, then in that scenario we will be directly adding up now dp of ij equals to dp of I minus 1 and j minus 1. Else means when both of the characters are not equal. So in that scenario we need to have minimum out of all these, and we can do one outside only because we are finding out the common out of them. So 1 plus minimum of, and this will be directly added up to this TP of I and j. This is that scenario when we are basically deleting. This is the scenario when we are inserting, and this is the scenario when we are replacing. So this is the thing which we will be doing. These are base case is now ready in state. This is state and transition. And in the tabular, for our base case, that we will be replacing by just one thing, that is we would be filling out our DP array, and that will replace our base case most probably. But that we need to check while doing our code. So now let me show you how we are required to do the code. So here first comes the part for recursion. So for recursion, first we are required to make a recursive function, and this is how it is. Means we are going ahead by passing the word 1 and then length of the word 1 minus 1, and then word 2 and length of the word 2 minus 1. Now here we are ready with our parameters. Now comes the part, this is the base case which we are taking, that if our length is basically less than 0, then we would be returning m plus 1. If our length is if our length of the word 2, if it is less than 0, then we will be returning n plus 1. That is, we would be directly returning the opposite ones, that whatsoever length is remaining. And this is that scenario. See, if we take cat and cute, that example only. So if by let me add arbitrary character, if all these are now done, right? So if at the end say here we have this d also, and all these had been cut in some scenario. So now here we are left, right? Means there is one empty character. But this one is still left to be filled up, right? So that's why in this scenario, what we will be considering is the length of this plus 1. That is, we can insert this particular character into this one, and that will also make our particular word matching, or you can say conversion of one word to another word successful. So that's why what we are doing is we are directly checking that if first word becomes less than 0, then we will be returning the whole length plus 1 of the second word, or if the second word becomes empty, then we will be returning the length of the first word which is left and plus 1. So that is how we are taking the base case here. Now next thing which comes up is that if both of them are equal, that is the case 1, then we are directly moving ahead. That is, we are moving towards the 0th position because we are starting from the length. Else, we are required to consider those 3 cases: insertion, deletion, and replacement. And at the end, we need to return 1 plus minimum out of all these 3 operations. And this is what we would be doing in this DFS. And thus, at the end, we will be getting answer into this particular DFS, and that would be returned. So this is how we are doing our recursive solution. Now comes the part for the memoization. So for memoization, we need to introduce a 2D vector, a 2D array into the same for storing this particular. So now let me show you the solution for the same, how we would be doing for the same. So for that scenario, here again the base case remains the same, and we are first, because we have not declared this particular privately or publicly, basically we hadn't made it a global variable, and we have directly make it here only, so that's why I'm passing this as one of the parameter. Else if I would have made it a global variable, then I won't have passed it here. And here I'm directly taking a 2D vector in which I'm passing the word 1 length and the word 2 length, and initializing the whole 2D vector with -1, and then I'm passing it to this particular function, and then here the same base case, and then this is for that fact, means returning that subcase if my DP is not filled with -1, but then it would be surely filled with some other number. That's why I'm doing this. And then comes the part, the first case, that if both of the word are equal, then we don't do anything, and that's why we are directly returning this by entering that particular case into this. And then comes the else part. So for that else part, we are just first calculating all our things, and then at the end, at the returning portion, we are doing this. We have just inserted our vector here. So that's the thing which we are doing here. So this overall thing, elimination of all the subcases which we were earlier getting, basically those subcases which are basically duplicate. So this makes our solution as m into n, because now there is no exponential thing, means whatever subcases would have been duplicate, they are now stored somewhere and they are being fetched at this step. Now comes the next part, and that next part is about bottom-up DP. So for bottom-up DP, what we are required to do is, we first, the base case which I was saying, that base case would be replaced by basically this particular scenario, because now we need to handle everything with the help of the table only. So that's why we are doing all this. So first comes the part that what are the length of n and m, and for that scenario only we are doing all this. First thing is that we are initializing it. So for initialization part, although we hadn't taken here anything for initialization, we are just declaring with the length. Now the length is n plus 1 and m plus 1, n plus 1 number of rows and n plus 1 number of columns. That is the length here. Why we are taking that plus 1? So that we have that extra row and extra column where we will be putting our base case scenario. So this is for our base case scenario only, where what we are doing is that for each row which is there, we are directly filling up with I and then we are filling with J. That's what we are doing. Means basically if we are having this number of words A, B, C, one row is extra here and then A, B, C, so one row is extra here for this one and one column is extra for this one. So as we are filling from the length, so it would be filled like this. That's the thing which I am saying. That's how we are filling this. This is what we are doing here. Now comes the part that how we need to calculate in this particular. So we have taken a nested loop. One would be running for the number of rows and one would be running for number of columns. So first thing we'll check that is what 1, I minus 1 and J minus 1. That is, we are starting from 1, right? So that means we are starting from here. Now what we would be checking is that we'll check that I minus 1 and J minus 1, that is at this particular point. So here it is already empty, right? Here it is empty and both of them are equal, right? So this one would be directly skipped and this value which was 0 here. So now at this particular point, that is 1, 1, it would be having 0 value. So that is how it will be starting. Now comes the part, then we come to this B and C. Let me replace the character, else I won't be able to explain. Now comes the part that we now had it towards I was equals to 1 only and J equals to 2. So in this scenario, now J is equals to 2, now it comes here and I is still 1, then A and B, both of them are unequal, right? So it will check out of these three scenarios which is there. Okay, my cursor is not visible. Out of these three scenarios, we will be saying that which one is the smaller operation which can be done. So we will take that I, J, I minus 1 and J, right? So we will be taking that what is being filled at I minus 1 J position. So I is basically at A, I minus 1 is 0 and J simply reflects this particular position. So at this position we are having 1, right? So here it will be filling up of 1. So now comes the part of this particular I and J minus 1. So I is basically 1. So it is here and it says J minus 1. So J is basically 2. So it comes again at this particular position. So again it is 1. And this I minus 1, J minus 1 comes out to be 0 because it will head over to this particular 0th position itself again. So minimum out of them is the 0. So that's why at this particular position, when we add 1, because we did one operation, so at this particular point, when I equals to 1, this equals to 2, then we are having this one as an answer. Now comes the next part, when J equals to 3. Now we are at this particular point. So when we are at this particular point, so what we are required to do is, we'll now again both of them are not equal, right? So when both of them are not equal, so at that particular scenario, what we will be doing is, because C and A both are not equal, so again we will be checking, and when we checked both of them, then what we got, that we need to check. So here we can see I minus 1, J minus 1. I is equals to 1, J equals to 3. I minus 1, J minus 1. So if we insert, then is that if we delete basically, first I have written about delete, then it comes to this particular point, I minus 1 and J equals to 3. So it remains at the same. So it is at this particular scenario only, means it is at this block only. So here we come with 3. Now j minus 1, that is it reaches here, but it need to be at I only. So it reaches at this particular point, that is 1. So this comes out to be 1. Then I minus 1, j minus 1. So it comes out to be 0. So then again it comes out to be 0. So that's why minimum out of them we got 0, and that's why this undo is not working. So that's why again at this particular point we are having 1. So like this only we will be able to fill up the hole, and at the end, because there is just one replacement, that is of the C, so here we will be getting 1 as our answer. So that's why we return dp of nm, because whatever answer we will be getting at the last mode cell only, and that's why we are able to return dp of n into nm. That is the last state which we are required to return. Here also the time complexity would be order of n into m, because you can clearly see that we are using a nested loop, and now comes part of space complexity, that is also n into m, because you can see that we are using this particular table, and this table is being made by this 2D vector whose length is n and m. We can discard the plus 1 because it's negligible in context to n and m. So that's why our space complexity is n into m. So this was all for this particular question. If there's any doubt, you can comment that down. So as we are starting with the DP question, so I know that whenever we start with DP question, so we always try to start from Fibonacci series. But today I won't start with Fibonacci series. As I already mentioned that what I would be doing is, I will be doing with the subtopics of DP series, right? So for this time, I will be selecting and going ahead with the LCS. So for LCS, we would be doing some 8 questions, and after that, we'll switch over to another DP topic, basically DP subtopic, and that would be LIS, or we'll choose that which one we want to go ahead with. But now, for time being, we'll be going ahead with LCS, and as I'd already mentioned that how I would be doing is that first I'll show you how we will be going ahead with recursive solution, and after that we would be going ahead with memoizing the same, and then going ahead with the bottom-up DP. So this is how we will be doing our first question for the day, and that is the LCS. So this is a base question for a lot of questions, because as we go ahead with this LCS question, then after that only we would be able to do a lot of questions which are related to this. So that's why we need to maintain the consistency and do daily one of the questions regarding LCS, so that we are able to recognize the pattern that this is the LCS question. So let's start with the first LCS question today. So as you can see that I've taken this example ABCDE and ACE. So the basic meaning of LCS is longest common subsequence. So first comes the part that what is subsequence, what is substring, and what is subset, right? So as this question requires subsequence, right? So for that portion, I'll let you know that what a subsequence is. So basically, when 2 strings and common class are there, and now here comes the part of subsequence. So for subsequence, we need not to be having consecutive elements which are there, but we are required to have all the elements which are present in that particular string, basically the chars which are present in that string. They need not to be consecutive, but they need to be having the same relative positions. Means when we are having this A, B and then C, then what is the subsequence? This ABC is itself, it is not a subsequence because they all are consecutive. But if we have something P here, then A and then B and then C. Basically now ABC from this particular string would be a subsequence. But earlier alone this ABC was not a subsequence, but A and then C, if we take them, then AC was a subsequence. So this is a thing which we are required to take in this particular question, and which we would be doing in this question. So now comes the main part, that how we are required to do this question. So as it mentioned that we are required to find the longest common subsequence. So now you know that what is subsequence, right? So now comes the part, the common. So for the common part, we would be given with the two strings which are there, means this one and this one. Two strings are given, and in that we are required to figure out the subsequence, and on the aspect of being common, we are required to figure out the longest common. So that is the thing which we would be doing in this particular question. So now, before doing this question, let me show you that what are the constraints for this question, as I haven't mentioned constraints here. So here you can see the constraints of this question are till 1000, means minimum 1 would be there and at max 1000 would be there, and it only consists of lowercase English characters only. So that's why we are just required to keep a check for the lower English characters only, and then as the constraints are such a lower, so that's why we can apply DP on this question. So now let me explain you that how we are required to do. So first comes the part about the recursive solution. As earlier only I told that first we are required to check for the recursive solution. So here's the thing. Now whenever we are given with that which one we are required to choose, right? So in choosing and non-choosing, there comes the part of recursive solution, and for that aspect only we will check that how we are required to choose and not to choose. So that's why for this recursive solution, first comes the part that what are the choices which are being there, right? So for the choices we are having that either we need to take this particular character, or we are not required to take this particular character. So that is either we are required to take it or we need to skip it. That is the thing which we are required to check in this. So this is the first thing which we are required to do in a recursive solution. Now comes the next part, and that part is the base case. That what is the base case of this question? So the base case here would be that we would be see how we are required to check about the base case, or before getting through the base case, we are first required to check for the recursive, means the recurrence relation of this particular recursive solution. So here comes the part that what would be the recurrence relation of this particular question. So the thing is that because we are required to check for the common and non-common, right? So what we would be doing is we will be checking that if this particular both of them are common, right? So in that case, what would be the thing which we would be doing? See, as per the question, we are required to find common, right? So we'll check that as it is common, right? So here we found one character, so that's why we will be adding 1, right? Now comes the part that as we have already chosen, so now we need to move ahead, means for both of the strings we will be directly going ahead, means in this first string also and the second string also. And for the part that when we are required to skip it, right? So there could be a case that by skipping one character from the string 1 or skipping one character from the string 2, we can figure out with the common characters, right? So in that scenario, we will be doing this particular thing. So in that scenario, what we would be doing, then in that thing we will be doing this, that will either skip first one or we'll skip the second one. So that's why we'll check that whosoever returns the maximum out of both. So that's the thing which we will be doing here. So in this recursive solution, now we are able to figure out that what is the recurrence relation here, means we are given with two strings, and in those two strings, if there is common, then we'll skip both of the strings and we'll add one that we have already found, one of the character. And if we are unable to find characters there, means common character, then we'll either skip from the string 1 or we will skip from the string 2. So that is the thing which we will do, and out of them whatever would be the maximum, we'll keep that in our skip variable, right? because we are required to figure out the long case, and that's why we are doing maximum out of both of the cases. So that's the thing which we would be doing here. Now comes the part that what would be the base case, because in a recursive relation, when we are going into the depth of a particular recursive tree, then there should be a base condition at which it is required to stop. And as in this particular string, we would be traversing the whole string, right? So there we can give a constraint about the string length, right? And it exactly depends on our recursive relation, that either we are moving ahead, that is moving towards the end of the length, or we are moving backwards towards the zeroth character of the length. Means either we are moving towards the n-1 character, or we are moving towards the zeroth character. So according to that only, we are required to give our base case. So here we are moving towards the n-1 character, so that's why our base case is that if n equals to the size of the s1 or n equals to the size of the s2, then we will be returning 0. So this is how we would be determining our base case. So in a recursive solution, first we need to check for the choices, then we need to check for the recurrence relation, and after that we are required to check for the base case. So this is the thing which we would be checking in our recursive solution. So for this only, for better explanation, I have already made a particular tree. So how it would be that if we check for S0 and then is S2 0, then in both of them we are having A. So both of them are common, right? So then it will go into the depth of that particular by skipping both of them and adding 1 to the same. So now 1 is added to the same, right? Then it will check for the first character, because earlier it was 0th character. Now it will be checking for the first character of S1, and then it will be checking for the first character of the S2, and both of them are not same, right? So that's why at that position only, now we are having two cases, that either we need to skip for the string 1's character, or we are required to skip for the string 2's character. So that's why in that context, what we will be doing is, we'll then further move ahead in this particular tree, and then we will be directly checking that whosoever is returning the maximum. So in that scenario only, we'll check that either of them, then we'll first go into the depth of the first condition, then we are checking for the, means basically when we are skipping for the first string's character, so that's why we are checking that CC is there, right? So both of them is a match. Now as both of them is a match, so we'll add 1 and skip both of the characters, means both of the strings, and then again go ahead with the same thing, that either we will skip for the string 1's character or we'll skip for the string 2's character. And like this only we are moving ahead, and at the end we reach at that case when n equals to size of the first string, right? So that's why it started for, and that's why it started for backtracking at that position. So this is where our base case comes into picture, and this is the thing which we are required to do, and now our answer would be being calculated after this only. Means now it will be returning, and here 1 got returned, and then after that again 1 got returned, and then 2 got returned, because here we encounter with the 1, right? So like this only it will be at the top, but before reaching the top, it will also check that are there any other conditions which are still being left, means this condition which was left, right? So it will check for this one, and when its base case hits, then only it will move towards its parent caller, means a complete recursion with a complete recursive stack. And this is how, means when we reach a base case, then only our stack unwinds, and that's the scenario. Means here only whatsoever the things which are there, means all these which are there, then it got unwinding. So this is the thing which we are doing here. Now comes the next part, that now we are having a basic understanding of this recursive solution, right? Now how we are required to code this particular solution. Now that's the thing. So for this particular, I don't remember that I have written here. So the recursive solution for this particular question is this, that here means our function which was given to us was this one. We are given with two input strings, and in these two input strings we are writing our own recursive solution here. So for that recursive solution we have named it as sub, and here we are passing with the input string and then the starting point, and then string input string 2 and the starting point for the input string 2. So this is the thing which we are going to pass here. And now comes the part that how we are going to code this question. Now, as I already mentioned, in the recursive solution we work on the choices, on recursive recurrence relation and the base case. So here comes the choice part, that either we have to take it or we need to skip it. So that's why we have declared here the variable in take and skip equals to 0, because this is a starting point. Now comes the part of the base case, that if it reaches the end of the string 1 or it reaches the end of the string 2, then we are required to return 0. And that is the thing which we are doing here. Now, if f1 of n equals to f2 of m, here n and m are basically the variables which we are required to take for going ahead in our question. So then at that point we will return our particular function itself with passing the parameters n plus 1 and m plus 1, but adding 1 to it, the thing which we were doing in our that recurrence relation. And here then at the end we'll return skip equals to maximum of sub of, either we'll skip the first or we'll skip the second. So this is the thing which we would be doing. So here's how we would be coding this particular recursive solution. So this is how we can go ahead in the interview time, and this is how we can first explain this particular point and then we can do memorization of the same. So yeah, and if we do all this in the interviews, then that will surely make possible for you that you know the basic understanding of this question. So it would be pretty much good. So yeah, so for interview perspective this all is there, and now I'll show you about the memorization and bottom-up DP. But before showing that from interview, I just recall that I was about to tell you that who has supported this particular channel. So for the same I can show you that. So basically this particular channel is supported by Newton School, because the thing is that a lot of students ask me a lot about to giving them details about a course which is well structured and gives them live guidance and personal mentorship. So I just came across this course, and here you can see that programs for fresher, you can pay after the placement, and this is the one of the most attractive thing I got about this course, because you don't need to pay beforehand. When you will be placed, then only you are required to pay for the course fee, else you won't be required to pay about the fees. Means you don't need to pay beforehand. That's the one of the greatest thing about this. And now comes the part that how we are about to do the memorization about this particular question, right? So here's the recursive solution, and now comes the part about the memorization. So for memorization purpose, we all know that for why we do memorization. It's all for the case that in the recursive solution there are a lot of cases where we are required to means there are a lot of sub cases which are there with repeat itself, right? So that's why in the memorization what we do, we simply take a vector of vector int, right? Or we can take a vector of int, or we can take any array, or we can take any unordered map. And how we are required to take these things means choosing a 1D or 2D, means how we are required to memorize a particular solution, means a recursive solution, right? Because here also we have taken this vector of vector int, right? Now this part comes to our mind, means how we are taking this 2D or 1D. So here you can see about the choices. So what choices we make? we made that either we need to take it and need to skip it, right? But the thing is here we are not going ahead, means for the fact of that this vector int, basically this 2D and 1D, for that fact we are not going ahead with choices, but we are going ahead with the dimensions which we are taking here according to the input string which is there. Means see, how we are making our choices is that either we are taking this particular string or we are taking that particular string or we are taking both of them together. So here the variable part is that we are choosing this particular string or we are not choosing this particular string. We are choosing this particular string or we are not choosing this particular string. So here there are two strings, right? So because of these two strings only, we are going ahead with this two-dimensional vector. In C++ we can go ahead with vector, in Java with the array list which is there. So according to language that changes, but as I'm coding in C++, so that's why I'm taking this vector or vector in. So how we are memoizing this particular recursive solution? So everything is same. The way means every portion is same. Only portion which is different is this particular, means I have taken a data structure, a new data structure. Then comes the part this, it is already same. Now here comes the part. But means before going ahead with the same, okay, I guess it will become much small. So before going ahead, in the main portion of this question only, I have first, means earlier I have defined that vector int as publicly, but I could also define it as private variable also. But in time being I have defined publicly, but prefer to define it as private variable. So here, now what I'm taking is, doing is I'm directly resizing this particular DP. So here I am resizing it with the first string size and the second string size +1. The +1 is simply for the base case that we are passing, and this -1 means that this would be acting as the what we can say as an indicator that yeah, if it is -1 means it don't have any value earlier, so we won't be getting any particular answer from our DP. If it is not -1, then a sub case is already stored at that particular position, and then we will get our answer from there. So that's why we are getting -1 here. Now comes the next part, that is if DP of nm not equals to -1, the thing which I was saying earlier. If that is not the case, then we are required to return DP of nm, right? This is the thing. This is the only change which we are doing here, and next one more change is there. So this was already the same, the base case which was there, but here rather than returning 0 directly, here we will assign that 0 to our vector or vector int, and then we will return that particular point. And then comes the part about this particular, that if both of them are equal, then what we'll do, means earlier we were directly returning this case, right? Now we will first assign it to our DP, and then only we will return. And for the next case where we were having that skip portion, right? So for there, first we will assign it to our DP, doing the same thing, and then only we will return. So this is the thing which we will be being transformed from a simple recursive solution to a DP solution. So this was all which we are required to do for memorization part. Now comes the part about the bottom-up DP. I hope now it is much clear from recursive to memoise. Now comes the part for the bottom. So about the bottom-up, see, the thing is, as the name suggests, it is bottom to up, right? Earlier it was top to bottom, means we were going ahead in that manner that whatsoever was stored previously, we were at the top and we were just making our getting our sub cases and then getting the answer from that. But here the thing is somehow different. So that's what we are required to go ahead with. So now, for doing this particular, again, as it is recursive only, right? Recursive changed to DP, that was that memoized part. But now comes the part that somehow it is also derived from recursive solution only. Only thing is some of the methods are being transformed, like the base case would be transformed into a tabular portion. And that tabular portion we need to keep in mind that how that particular base case is required to be, to be taken into consideration. So for that part only we make our row 0, column 0 at the first position. These are acting as our base case. Earlier what we had done was we have taken a vector int with the size just +1. That +1 was acting as our base case, means that particular position, that extra space. And now here also this extra space is acting as our base case. Now how it is being modified as base case, now you'll get to know. So now comes the part in tem and in tem. Means now we are taking the first string size and the second string size. Now we are defining a 2D array where the size is m+n, m+1 and n+1, right? And y+1 is there for that base case. And now first we are making all the rows at the first, means basically all the columns at the first row we are making them as 0. Then all the rows at the first column we are making that as 0, and that is the thing which we are doing here. So this all is acting as our base case for this particular question, for moving ahead with our bottom-up DP and making that tabular way of doing this question successful. So now for int I equals 1, because we have already put that I equals to 0 as 0, now we can access that also. So now we are starting from I equals to 1 and j equals to 1. Now in our inner loop what we are doing is we are checking. That is our previous. Now here comes the part. Why we have put our all first row and all first column as 0, because of this thing only. When we are starting from I equals to 1 and j equals to 1, now when we compare that our I-1 and j-1, if both of them are equal, yes, both of them are equal. And one more thing for putting them as 0 is, see, in means when none of them is matching, right? So that is means if we say that only one character is there, right? So if there is also not a match, so in that scenario also it is also one of the case that means at that point it will return 1. So that's why we are taking this 0, means it should be a match, and then at that point we are getting this 1 and adding this to our previous dp of I-1 j-1, means basically at the starting point only we are writing this. Else it will directly go to skip that I-1 or j-1 and check that out of them which of the maximum, and assign that to dp of I j. And this is the thing which we are doing here. You can pretty much see that in the recursive solution also we were doing we were directly skipping both of them, or we were skipping either of them. That was the thing which we were doing in our recursive solution, right? And the same we are doing in our bottom-up solution also. Only thing is that now we are doing it all in a tabular form, so that's why we are filling a table and then extracting a value. That is the thing which we are doing here. And when it was recursive solution, it was simply that we need to keep in mind about the recursive stack, how it is unwinding, and all such things we were required to do there. And now at the end, what we would be returning is dp of m in, because this is that position at which we will be able to find the longest common subsequence. Because what we are doing is we are directly adding 1 at every position when we found that they are common, right? And also we are checking that what was there at the previous position. So that's why what would be the next would be the summation of previous one and the present one. So when this is the scenario, then we get our answer at the end position, that is dp of mn. and that is the case here. We are getting a solution here. So this was all for this question. Now comes the part for the time complexity and the space complexity. So the time complexity will be n into m and the space complexity is n into m again, because the thing is that we are taking a table, a 2D vector, means table is for the from that 2D vector only, and how the time complexity is n into m because of the fact it's got okay. So why the time complexity is n into m, you can clearly see that there is a loop of m length and then there is a loop of n length, and both of them are nested one, and that's why when we are going ahead with a nested loop, so here the time complexity becomes n into m, and that is the scenario here. So, and space complexity because of this table which we are taking of n into m length. So this was all for this particular question. If you have any doubt, you could comment down, and do like and subscribe to the channel. LeetCode question distinct subsequences. So today is the third day for the DP series. So here's the third question in front of you. So basically, you need to first figure out that this question is similar to which sort of question, and then we'll proceed with the same. So first, let's check out and check for the explanation of the question at later moment. First, read out this question. So for that part, given two strings s and t, return the number of distinct subsequences of s which equals to t. So this is the line, but somehow let us know about that. What sort of question is it? That two strings are given and we are required to return the subsequences, number of distinct subsequences of s which is equals to t. So somehow we are required to check out for the similarity. And now next thing is a string subsequence is a new string formed from original string by deleting some, can be none, of characters without disturbing the remaining characters' relative position. That is, ACE is a subsequence of ABCDE while AEC is not. So here the thing is that in this question we are required to return the distinct number of subsequences which could be formed, and these subsequences should be equal to t, which is given to us as the second string. So this is the thing, is basically a pattern matching sort of question is this. But another thing is that earlier also we had done with the DP question which was similar to it. So just think about this, that which type of DP question is it, in which we are required to match two words, and then after that we are required to go ahead while comparing each of them with each other and so on. So yeah, this question is basically the variation of LCS, the longest common subsequence. And here we are not required to return a longest common subsequence, but here we are required to return distinct subsequences. Here the commonality part is basically on the basis of t, which should be equal to the subsequence which we will choose from S. So that's the thing which is here. So now let us check. Next thing is about the constraints. So our constraint here is that S and T are basically up to 1000 only, and there will be at least minimum one character in our string. So now let us check for the first test case, which is here. So here we are given this rabbit and rabbit, and how we can form this particular, that is the thing which is given to us. So here you can see that if we write this rabbit, so we can figure out that this particular green means all these greens figure out with this rabbit similarity. So that is means the green portion is the first one, then the pink portion which is there means RA, and then B, and then skipping this B and then taking the other B, and then I, and then T. So this is the second, and the blue one, that is the third one, that is taking all till A, then skipping first B, and then taking both the B and then I and T. So this is how we are able to figure out three ways in which we can form this rabbit. So basically there are three subsequences which are basically equals to RT, means that is this one, and this is our S. So now here you just figured out that how we are doing this. The way we were doing it LCS, that we were choosing or not choosing. And here the thing is that if there is a match, then only we will proceed with the present word, or we can also choose to not to proceed with the present word. You can simply see in this triple V case that we are doing two things. Either we are choosing this B or we are not choosing this B. So this criteria is only valid on that particular scenario, then there is a match. And here you can see that in this example everything is a match. So here you got the example for matching conditions. Now let us take one more example in which there won't be any match. So 1 minute, let me show you. Let's check that if this second, yeah, in this second actually there is the case. You can see that in this particular bag, we, no, this also, okay, let us consider this also. So in this particular, we can see this B and A, right? This, and then we got at Z. So now we got one match. So now next we check for the another iteration, and then we check again B at A. Then we are required to figure out with one more Z, right? So we just figure out with this one. And then we now skip that A and we just took this B and then now figure out with AG again. So now we have done with these three. Now comes the next part that these three are now figured out. So now we are checking for a new B. So here we got the B and here we got A and G, new ones. And this one is also done. Now we are required with some new sort of which was not chosen. So this was as a whole not chosen. So here, when there is a match, then we are basically figuring it out that do we need to choose it or not to choose it. That's the thing. And if there is no match, then we will directly move ahead. So let us take arbitrary example by ourselves. If there is a word, take commander, even if spelling mistake is there, then just discard that. And word is command. So we are required to check that this command, how many subsequences we can form here. So one is the direct this one, right? And the other one, if we want to figure out, then surely we won't be able to, because when we check for other this A and R, right, then this criteria there is no match. So we will directly skip these two words, right? So here we will skip these two words and we won't move anywhere in this particular word, in this word, but we will move only in this word. So that is the thing which I am trying to convey, that when there is a mismatch, then in that criteria we don't want to do anything. But when there is a match, then it's our choice that do we want to choose this particular or do we want to skip this particular. So that is the scenario. So according to this only, in this question, either we are required to choose or not to choose in that criteria when there is a match, and when there is no match, then in that criteria we will just skip our word in the S string and we won't be doing anything for the T string, because we can only proceed with our T string when we are able to figure out that there is a match. So this is the whole criteria we would be doing in this. Now comes the part that, okay, now we are able to figure out that what options we are having. Now comes the part that in this options also, how we will figure out that when we are required to stop. So you can clearly see that if there is a case see if there is a word cat and there is a word catalog, okay, and basically this is S and this is T, if this is the criteria, right? So you can see that this S which is there, this S is basically smaller than this T, and you can say that yeah, there would be a match at this particular moment of time, right? So at this moment of time you will be able to figure out that yes, there was a match. So here when this S is being exhausted, right, but still in this T we are having some words which are being left. So in this criteria, because there was a match, right, so that's why we'll directly return 1 here. That is the thing. But if there is a criteria that means catalog was there, but let us take another example. So the thing which is here is, see, when we were taking s equals to cat and t equals to catalog, right? And we were saying that yeah, we got this thing, but this is another way we can say that it is reverse one. Here even if it is a match, but this is not which we are required to find. We are required to find basically a subsequence which is equal to t, not equal to s. So that is the thing. At this point we are required to write a base case, and in that base case the thing would be something like this. That if s means, let us say its length is n and this length is m, right? So if n is less than m, means this case is there, right, which is in front of us. Or if another way around is n is less than 0. If any of these criteria is there, then we are directly required to return 0, because in that criteria, if s is completely exhausted, right, or if s is basically less than t, then we can't be able to figure out with a subsequence which would be equal to t. It is mandatory that t should be smaller than s. Else, how you can say that t is equal to any particular of s, right? So this is one of the things which is required. Now next thing which I was saying, that is s is now catalog, right, and t is equal to cat. Now if this is the criteria, then in that sense we will be returning 1. Why we would be returning 1 in this criteria? Because here cat, that is at t, is equal to a particular portion of s, although s is still remaining there, but t is now basically found a match in s, right? And now it becomes equals to -1, because now there is nothing left in the indexing part. So that's why there it will return 1, and that's why now we would be returning 1, because surely there would be a match. That's why t got exhausted, else t wouldn't have been exhausted, because we are taking a criteria in such a manner that if there is a mismatch, then we won't be moving ahead in our t. But if there is a match, then only either we will move or we will not move in the t. So that's why according to that only we are required to write this particular case. So does this make sense? Because you can clearly see that at s equals to cat and t equals to catalog, here you can clearly see that there is nothing when we can match it. But when s equals to catalog but t equals to cat, here we can directly match our t with our catalog, right? So this is the thing we would be doing here. Now comes the part that okay, these are the things, options are there and so on, but for which purpose are we doing all these? These are for figuring out all the things which we can, means all the things which we can write in the same. I mean all the cases which could be generated for all that criteria. It means from every option which we can choose, means every character we will be checking and everything we would be going ahead with, right? So there would be a lot of cases, lot of permutations, combination and so on things would be made in this case. So that's why this particular question is basically a question for recursion. And because as per the constraints, then we would be going ahead. So we would be required to memorize this particular solution, else our recursive exponential solution won't work. So now let us go through the more explanation of our recursion part, that how we would be moving ahead with the same. So here I explained you about the same. Now comes that what this question is about, that we are required to return distinct sequences of s equal to t, similar to LCS, because in that also we were inserting or deleted. So either we are required to choose it or not choose it. The only difference here is that if there is a match, then only we have option to choose it or not choose it. But if it is a mismatch, then we'll surely not choose it. So that's the thing which is here. So this was the thing which I was discussing earlier with you. So before coming up with these things, we are required to write a recurrence relation, and that is that if both of them is a match, the way I was explaining in these examples, then we would be directly doing by DFS of n-1, m-1, where n simply represents the size of string s and m simply represents the size of string t. So here the thing is that we are choosing it and thus moving ahead, and here the thing is that we are not choosing it, that's why we are staying at the same. Else if there is a mismatch, right, so we will only move ahead with the string s and not with the string t. That's why we are writing like this. We need to move ahead in our string s on a mismatch just because of the fact, because if it is a mismatch, then we surely need to check that is other character in that s being a match with our t. So that's why we would be only moving in our s. So this is the only tweak which makes it different from LCS, but although we are doing the same thing only of choosing and non-choosing over a match or a mismatch. So this was about its recurrence, relation, options are, I already told you what the options are, and the base cases I already explained that how the base cases we come up with, and these are the two base cases which we are required to write in the solution. So I think you would be now pretty much sure that how you are required to write this recurrence, relation, and then base cases need complete recursive solution. So now comes the part that after this recursive solution, how we are required to memorize it. So you can clearly see that here we are required with n-1, m-1. So this completely reflects that we are required with a 2D data structure so that we could memorize it properly. So according to that only, we would be choosing a data structure in which first we will be initializing with -1, and then after that we will be storing our results. Basically, we would be storing our result dp of I, dp of j equals to this particular, and then here dp of I, dp of j is equal to this particular, and we would be returning at this particular point. That is the thing which we will be doing, and at the end also we will be returning our dp of ij which would be there. So this is how we would be memorizing this particular question, and in the base case also, rather than directly returning 1, we would be returning by dp of ij equals to 1, and here also dp of ij equals to 0. So this is how we will be memorizing this question. I will show you the whole code about the same. Means this is the overview which I am giving you so that you could by yourself code it, and even if you get stuck, then you will analyze it and completely check that how it is required. Now let us come to its bottom-up approach. The thing is, the bottom-up approach is something like that. In this recurrence relation which all we were choosing, we just need to get this particular function itself, means this particular function which we are using, means all these recursive calls which we are using, we just need to transform this particular into a tabular form. That's the thing which we are required to do in our bottom-up DP. In bottom-up DP, we are required to come up with the state and a transition, right? So here the thing is that these two things which are there, they will be acting as a transition, and the state would be this particular thing which we were doing in our memorization part, and the base cases which are required to be covered. These base cases would be these which are there. So basically our base case would be now in our tabular form, and in our table only the first row and the first column, they will themselves be declared as if they are the base cases. See, here we can see that when m is less than 0, right? So at that moment only we are required to return 1. So what we can do in our table? In our table, what we will see is that we will make our first column completely as 1. That's the thing. And thus it will be acting as a base case. And in our first row, we will make everything as 0. So that will be acting as a base case when our n is basically less than m or n is less than 0. So this is how our base cases which were there in our recursive solution, they convert into a tabular format in our bottom-up DP. So let me show you that how we can form a bottom-up DP table. So here is the one I have already formed, so that means time is basically reduced while explaining. So now here is the thing is, as I already told, that we will make a first column as all 1 and first row as all 0. This is thing which we will be doing, and this will be acting as a base case for a DP table. And you would have been noticing that we are having one extra row and extra column, right? And this is the reason we take one extra row and one extra column, so that we are easily able to come up with our DP solution. And the way we would be making our transition, so that we could include our previous row or column just because of these base cases only, and we could directly come up to our answer, which would be stored at this particular cell. So this is the thing which we would be using here. Now, as I already told, the state is basically DP of ij. That is our state, because we are required with two variable parts. One is for the string s and one is for the string t. And the transition is basically on the basis of that if-else condition only, that if there is a match, then our transition would be again on the two cases, but we are required to plus both of them. Else, we will be just moving with our I only, and our j, it will be remaining the same in our this particular criteria, else criteria. Okay, so this was all about the explanation part. Now comes the part for time complexity and space complexity. So time complexity in both of the memoization and this bottom-up DP would be n into m, where n refers to the length of the string s and the t refers to the length of the string t, and the space complexity is also the same, that is n into m. But for the recursive part, the thing was, for recursion, it was 2 raised to power n plus m. Basically, it was exponential time complexity, but the space complexity, that was n plus m only. So that was the criteria for our recursion part. So now let me walk you through the code, that how we are required to code this particular question. So here is the coding part. I hope now coding part would be much clear after all this explanation. If still you have any doubt, then you could directly comment that down. I'll explain later. So here I've also commented the same, so that it will become easy for you for thinking of this particular solution. So now it would be much clearer. So here the first thing is, in this recursion part only, I'm thinking that's why I have taken this. Okay, actually that I was trying earlier only, that for memoizing it, but here in recursion this DP is not required. You can clearly see that I have not used that. So here in this particular recursion part, I will be returning this particular DFS function, and the thing is, I will be first taking this s and taking this t, and then s dot size minus 1 and t dot size minus 1, right? And basically why I am doing so is, here in this particular, I am here required to check for the fact that when my n and m basically at that particular criteria, just I am passing the sizes, and now here comes the part that choices itself, that if there is a match, then I will be going ahead with this particular function, that either I will choose or not choose, and I'll add up the result, that out of them which one is the maximum. That's the thing which I'm doing here, although I'm not taking that which is maximum or minimum, because here I'm required to get our distinct subsequences. So that's why after adding them up, means whatsoever result would be there in choosing or not choosing, that will get added up, and finally we will be able to get a final answer. And if we are not able to find a match, then we will just move ahead with that string f, and then that m would remain as it is, because we are not moving in a t. And here comes the part for our base cases. So first base case is basically when m is less than 0. So that simply represents that our t, which is required to be a complete match, then only we would be moving ahead. If it is less than 0, that simply means that we are required to return 1, surely, because there would have been match, that's why only it is exhausted. And in this second thing, if n is basically less than m, so that simply represents that our first string, that is s, was exhausted and we were unable to figure out with any match, or n is less than 0, that is all the same criteria only. So that's why at that moment we'll return 0. So this was what we will be doing for recursion part. Now let me show you that how we are memoizing it. So for memoization part, let me just comment it again. So for memoization part, what we are doing here, we are taking this particular, I was at starting, I was checking that how we are required to memorize. That's why I had written that. Now the same thing as we were doing in the recursion part, and here we are resizing it with the +1 size. Here you can see whatever size of string s is there, we are just adding 1 to it, because now that will be acting for our base case itself, and at the starting only we are initializing our DP array with -1, so that this will act as a flag to us that if it is not equals to -1, then we will return that subcase. So that is the criteria here. So here if m is less than, means these are the same base cases itself. Either we could return these base cases like this, or we could return these base cases by filling them into a DP of nm. That is the thing. So here as we are starting from the backward side, so that's why we are taking TP of nm rather than taking it as TP of ij, and also here also we are taking that as nm only. So that's why we have not written ij. Basically what I'm trying to say by ij or nm is that here we are going ahead from the last towards the 0th position. That's what I'm trying to figure out here. Not figure out, convey. So here, if it is not equals to -1, then we would be returning that DP of nm directly. Else, these are those cases only which were there in our recursion. Only thing is that we are filling directly to our DP here and then returning that straightforward. So this is how we are memoizing our recursive solution to means coming up with a top-down DP. So now comes the part for our bottom-up approach. So for bottom-up approach, here the thing is that here there was in some cases integer overflow, means there are some test cases which was there, although the constraints are in such a manner that they shouldn't be, but still it was getting. So for that fact only, we have just declared this particular, so that after adding up these cases, we'll do modulo for the same and we'll get our final answer. So here, how we are doing is, again we are doing the same step which we were doing in our top down, but at that moment we were initializing with -1 because that was acting as a flag for getting us know that is there a subcase stored or not. But here, why I've initialized with 0 is I'm basically doing that all at the one stroke itself, means our whole table would be now initialized with 0. Now comes the next part. This is that the first column of each row will be filled with 1, and this will be acting as a base case when m is basically less than 0. So that's why we are filling our DP table like this, and the whole table was already filled with 0 only, just because of this initialization part. So now comes the next part, that how we would be filling our whole table now. So yeah, now this is the thing which we are doing here. So for each row, we are starting from 1 itself and going till equals to n, because now we have taken our rows are basically n plus 1 and n plus 1 size, basically means they are going till n plus 1 rows are there, and our columns are basically m plus 1, so that's why they are going till m plus 1. Now we are starting from 1 to m. Now here is the case that if both of them are equal, right, then what we would be doing is we'll add up them and we'll do modulo, and if it is a mismatch, then we'll directly just move ahead with our I and just stop at that particular column of that particular character. That is the thing which we would be doing here, and at the end we will be returning our DP of nm. Why we are returning the endmost? The thing is that at this point either n would be exhausted or m would be exhausted, so that's why we are returning DP of nm. because either of them would be exhausted at that moment only. We would be able to get out of the this particular, and then we will be able to return it. So this was all for this particular question. If you have any doubt, you could directly comment that down. Yeah. And one more important thing, like as this particular channel is sponsored by Newton School, and even while as per my all other groups in which I post all these videos. So the thing is, like, a lot of students just ask me about the question that they required a structured course for the placement preparation and so on. So that's why for that particular thing, I just take a look at this course structure of the Newton School. So in that thing, I just figured out that they are basically not taking any particular upfront fee. They are just concerned about your placement. They are providing the packages from 5 LPA to 40 LPA, and the thing is that they will be providing you one-on-one mentorship. A structured course would be there. Your doubt solving sessions would be there. Means everything would be there for your placement preparation. So I just find it out that it is a good thing to enroll. So that's why if you really like this particular course, whose link is basically in the description of this video, so you could directly enroll in the same, and you could find further details for the same in that particular link itself. And as there is no upfront fee, means you need to pay the fee only when you are get placed. So I feel like that this is something which you should try for the same if you are not able to get placed till now. So today we are going to do TP series third question, minimum ASCII delete sum for 2 strings. So basically this question, as earlier we were doing LCS questions only, so I have taken third question also on the similar pattern only. So this is also one of the variation of LCS only. And today I will let you know about the recursive method, the memoization and the bottom-up DP, and of course how you would come up with all 3 approaches, and then at the end about the time complexity and the space complexity. So stay tuned for the same till the end. So because the thing is that it could become lengthy as usual, because you had seen earlier videos also had become 30 minutes and so on. So this might also become that much lengthy. So let us start. So first thing, in our question we are given 2 strings S1 and S2. We are required to return lowest ASCII sum of deleted characters to make 2 strings equal. So the thing is that in this particular question we are given 2 strings, and in them we are required to select those characters. After deleting those, we can make the string equal also, and they are adding up as the minimum sum to our final answer. So these are 2 things which we are required to consider. So what 2 things are? First thing is that it should have the lowest ASCII sum of deleted characters so that it could make 2 strings equal. So these are the 2 conditions which we are required to fulfill. So yeah, let us now check for the examples which are being given to us. Then I will show you that how we can think about the same. So here we are given with C and E, and you can see that the sum is 231. And as per the explanation, they are saying that we are deleting S from C at say ASCII value of S115 to the sum, deleting T from E at 116 to the sum. At the end, both the strings are equal, and 115 plus 116 equals to 231 is the minimum sum possible to achieve this. So this is the thing which we would be doing in both of the strings which would be given to us, deleting one of the character out of both of them, and then after that we will add up them, and then they would be, actually we would be what I can say, because surely the words that I am saying it would be confusing. So the clear cut thing is that we are required to check one character from the first string, one character from the string 2, and both of them should be minimum of all, and then we need to add up them, and that would be the minimum sum which we would be returning. And after deleting from first and the second string, the remaining string would be equal. So this is the thing which we would be doing. But the thing is, here it could be possible that there is just one character which is deleted from string 1, or there could be more than one character which are being deleted from either of the string or both of the string. So this is the thing. Now let us take for the constraints. So the constraint is that both of them can at max go till 1000 characters, and the S1 and S2 both are having the English lowercase letters only. So as per these constraints, here recursive method we can go ahead, but then the recursive method, because the thing is that we are required to go ahead with all the choices, and because of all the choices only, the solution would be simply in the exponential time, and that's the reason we would be required to memoise it so that it could go ahead with n-square solution. So yeah, and if it will go to n-square solution, that is valid for the same, because if it is n-square, because here the thing is 10 raised to power 3, and in this order of n and then n square, that would be 10 raised to power 6, right? And that is also acceptable, and it won't give us TLE. So that's why here n-square solution would work. So now let us go ahead with how we are required to do this particular question. So here I have given the explanation. So it is similar to LCS, where we were having the longest, and there also we were about to say choose or not choose. Here on the basis of minimum, because at the end we are required to run the minimum sum, right? And there we were checking for the longest common subsequence. So we were going ahead with the things that at every stage we were selecting the maximum out of both of the choices. But here what we would be doing, minimum out of both of the choices. So presently I'm just building up the context, then with the example I'll show you that what all these things I mean. And the second thing which we are required is that add that minimum to final answer at each step of moving ahead. So let us take this first example and go ahead. So here C and E, which was given us with the first example. So we selected as S, whose ASCII value was 115, and T, whose ASCII value was 116, and adding up both of them gave us 231, right? And after deleting them from both of the words, what we got, it was EA and EA, and both of them are equal, right? So we got a desired result with the minimum sum of deletion. So this is the thing which we want to achieve. Now comes the next part, and this is the main thing which we are required to do. So see, then we are required to choose a particular character or not to choose, right? So here tick simply represent that we are choosing from the first word, and cross simply represent that we are not choosing from the first word, and that is we are choosing from the second word. Now here you can see in the first, if we are choosing from this first word, right? So SE and A has been deleted, right? So A comes into this sum, and now here I am writing just with the alphabet, although the ASCII characters, ASCII values of these particular alphabets would be added to this sum. But here, just for convenience and not for just remembering that what the ASCII value is there, so that's why I'm directly writing the A character. And EAT would be as it is, right? And if we see for the next, when we are not required to choose from the first word, but we are required to choose from the second word, so what we are doing here is, we are directly writing this T here, and then in EAT, we are deleting this T and then writing this, and in the sum we got the T. So this is at the first stage what we got. But still, they are not having any of them equal. So now let us go to this particular branch completely and check when we can get to them. So now we can select or not select. Again, two choices we are having, right? So till now in our sum was having A, and then in that we deleted from first word, that is we deleted E. Now there is S and EAT. So in our sum we got A plus E, right? And then again we have to choose, not to choose. So when we have choose from the first word, in this what we can do is we just chose from this first word, and now we chose, so S, E, A, all three were in the sum, and T was already there because of this particular, and then again we will be moving ahead and completing this whole word. Now because of the fact, because one of them completely became blank, right? So that's why now we will be making other also blank, because now there is only one possibility to make them equal, that is making both of them blank. So that's why at this particular position we are returning with T, and then again it will be coming up, and the whole particular this would be returned as it is. Means basically eat and then EA, that also would be returned. Means whole of them would be returned at this particular position. And same is the case for this particular branch also. When we are not selecting, then again, here again blank becomes, so now every letter would be returned. And here also again the same is the criteria which will be going ahead, right? So now you can see that every letter is returning, right? So when our answer will come. In some of the branch, here when we are not choosing it, means in this particular case, when we are not choosing it, then SE and EA comes, right? Then again the same criteria follows the way in these branches were there. And here again the same thing is following the way here it was. So now let us see in this particular branch, are we able to do so or not? So now here we see that now we were having only T at the first most level, right? Now we come up to second level, and in this level only we see that here you can see that A is equal and here A is equal, right? Both of them are equal already. So why we would remove any of them, right? So now what we would be doing is, we will be moving ahead with both of the pointers from the both of the words towards the next word, that is E. So now again both of E and E are equal, right? So why we would ever eradicate any of the words from them, right? So that's why now we will be moving more ahead. Now the pointer comes to S and the other pointer comes to -1, right? So now at this particular point, the thing would be when one is less than, right, and the other one is basically at the 0th position, right? So here T, which was already there, right, and the other letter at which the pointer was, it would be returned, right? Because here again the same case is there, that E and A were equal, okay, but still one of them got exhausted. So whatever remaining string which would be there for the other word, now that would be also removed so that both of them become equal. And here you can see the case that E and EA are now equal when S is being removed and T is being removed, right? So now this becomes our answer rather than when all of the words were being returned, right? So this is the one where the minimum possibility is there that T plus S, when we add them, rather than adding up SEA plus EAT, all of them, right? So this is our desired answer. So now from this example, what you can see? You can see that whenever both of them are equal, right? So we will be skipping both of the characters, right? And when both of them are not equal, then we will be either choosing from the first word or we will be choosing from the second word. So this is the thing which we are required to do here. Means this will contribute to our recurrence relation. And now comes the part about the base case. So you can see that all of these strings are like at either moment of time, any of the string could exhaust, right? So here comes out the base case that when either of them gets completely exhausted, then at that particular moment only, if other string is still remaining, then our base case would be that we will be adding up all the letters which are being left in our other string, and this is how it contributes to our first base case. And there is one more base case. If all the letters are equal, right, or if all the letters are unequal, if that is the criteria, then both of them would come up to 0 at the same moment only, right? Means both of the strings will get exhausted, right? So in that criteria, our second base case would be that both of the pointers are now 0. So that's why we will be returning 0 at that moment, because at that time we won't be deleting any character. So that's why we would be returning 0. So this was like verbal explanation that how all things would be done. Now let me show you, because I have also written it, because I know that just verbal explanation is not enough. So here comes the part for recursive solution. So for recursive solution, the first part comes up for the recurrence relation. Before thinking about the base case, we are required to think that what options we are having and how we are required to come up with the recurrence relation. So here the options are, either we are required to choose one char from the word 1, or we are not required to choose char from the word 1. That is our options which we are given this. Now here comes the part that according to that only, how we are required to write a recurrence relation, and from that how we will be coming up with a recursive solution. So if both of the characters are equal, the way their EA and EA, in that AA were equal, right? So we were skipping, right? So here also we will be skipping. That's the thing which we will be doing. And if both of them are not equal, right? So in that case, we will be keeping we will be choosing from either first word, right? And then moving ahead by skipping that particular index, or we will be choosing from the second word and moving ahead by skipping that index. That is the thing which we will be doing. But out of them also, we will be choosing minimum. So that is what we are doing here. So this was about the recurrence relation. Now comes the part about the base case. After recurrence relation, we are required to stop that particular solution also, right? So for that particular thing, we are required with the base case. So if one string exhausts, then we need to return other string as well, right? So if both of these strings exhaust, then we are required to return 0. So these are the two base cases which we are required. So this was about the recursive solution. I'll show you the code at the end. But now comes the part that this recurrence relation would surely go to 2 raised to power m plus n time complexity, right? Because we have two choices and total m plus n time we would be having those choices. And the space complexities goes till order of m plus n, because at max the recursive stack would fill up with m plus n. Now comes the part that if this would be the time complexity, then surely our solution will give us TLE as per the constraint, because the constraint was 10 raised to power 3 for the length, right? So in this criteria, what we would be doing is we will memoize the solution. And how we are required to memoize it? So the thing in the memoization is choosing a particular data structure, and how we are required to choose that on the basis of what are the variable parts in the same. So here the variable parts are two, that one is for the first string and the second is for the second string, because these are the two variable parts on the basis of which this whole recursive solution is ongoing. So that's why we would be choosing a 2D either vector, either array, means a two-dimensional data structure we would be choosing here. And then first we would be initializing that with -1, so that could act as a flag that if it is not -1, then surely it would be having some subcase in the same, because you can see in this particular recursive tree that here subcases were there. This particular red portion and this particular red portion, both of them are repeating, right? So we are required to avoid these subcases. So that's why we are memoizing it. So for avoiding this particular subcase, so we are just going ahead for the same, means a 2D vector would be used, and then a -1 as a flag would be used. And now comes the part for the base case which we would be handling there. So the base case would be the same, the way we are using in this recursive solution. And yeah, these are few things which we are required to do. Else, if any other thing is that I'll show you in the code, because these are the overview sort of thing. And now comes the part for the bottom-up solution. So for the bottom-up solution, the only thing is, now it was just memoized, right? And now it is using functions. In the bottom-up, we would be completely transforming this particular solution into a tablet form. These all the functions which are used here, now these functions would be completely converted to that 2D data structure. Means instead of this function, we will be writing dp of n-1 m-1. That is the thing which we will be writing here. And instead of this minimum of s of n-1 plus function of n-1 comma m, we will be writing s of n-1 plus dp of n-1 and that m. Basically, they would be indicated now as the indices of that particular dp. And this is how we will be transforming this particular solution into a dp solution. And in that dp solution, the base cases would be handled by making a dp table in such a manner by adding one extra row and one extra column. And by that thing only, we would be able to come up with a base case. Here, our base case was that if both of them are exhausted, means both of the indices are 0, then at that case, we will be returning 0. So there, the table would be formed something like this. Means when both of the indices are 0, right? Means here you can see I is basically less than 0 and here j is basically less than 0, so it is 0. But there was one more case, when I is less than 0 but j is greater than 0. Then in that criteria, what we were doing was, we were returning the previous value which was stored there and the present value which was there. That was the thing which we were storing. But here you can see the previous value is 0, right? And the present value, because of these things only, it will be remaining 0 as well. Means the whole row and the whole column, it will become 0. And then here the things would be filled on the basis of the cases which we were using in our recurrence solution. So this was whole explanation about this particular question. And the time complexity and the space complexity, as usual, it would be order of n into m. And the space complexity, that would also be the same for both memoization and bottom up. So now comes the part for the coding of this particular question. So for coding part, let me show you how we are required to code it. Yeah. Let us first start with the recursive approach of this particular question. So for recursive approach, here you can see that how we are doing. This is our main function which is there. So we are starting from return minimum top down. We are putting the parameters as the word, then second word, then a size of the first word, then size of the second word. That is, we are passing as a parameter, because we are required with the word itself and the size of that word also. And then at the end we are returning 0 here. If so, this was the thing. Now comes the part for the base cases. Here we are having the two base cases, that if m equals to 0 or n equals to 0, then we will be returning 0. Else if m is less than equals to 0, means one of them is less than 0, then what we would be doing, we'll check for the other word, whatsoever letters are remaining, we'll directly add them up with our answer. That's the thing which we are doing here. Or if other way round comes up, means if n is less than equal to 0, then in that criteria we will be adding up this a of m minus 1 and the whole function. So now in this else part, this is that part when n is also greater than 0 and m is also greater than 0. So in this criteria, now we will be checking that if a of m minus 1 equals to b of n minus 1. If both of the characters which were previously there, if both of them are equal, then in that criteria we will be moving ahead. Else, if both of them were not equal, so we will either check for the first character or we will check for the second character on the basis of which of them is minimum. So this is the thing which we would be doing here, means this particular. That's the thing which we are doing here. So this was for a recursive solution. Now this whole thing would be done as it is in a memoization also. The only thing would be that a 2D vector would be added, that is this particular. And here the thing would be that the size of this particular would be +1. Earlier the size was basically, you can see, it was the directly as it is, the way it is. But here we have taken one extra space also. That would be for handling our base cases. So here at the first we are checking that if there is something in our particular vector, if there is something in our vector, then we will be directly returning from here. And if we reach a base case that both of them are equal to 0, then in that particular criteria we will be assigning 0 at that particular position. If m is equal to 0, then we will be checking for our b, that is for our other word. If n is equals to 0, then we will be checking for our other word, that is a and other solution. And if both of them are equal and both of them are greater than 0, then in that criteria we will be directly going ahead by skipping these indices. Or other way around, if both of them are not equal, then we will be checking that which of them are basically minimum out of both of them. So this was all for the memoized solution. Now comes the part for the bottom-up DP. So for bottom-up DP, what we are going to do, let me comment that down, because else if I run this particular, then it could be like, so that's I don't want to. So here comes the part for our bottom-up DP. So here in bottom-up DP, we are first directly passing as it is. Now in this particular, We are first initializing. Here you can see that I hadn't taken that vector or vector which I used to take. Here I have just directly taken that array. Now here comes the part for this whole bottom-up DP. So in this, what we are doing, we are using to loop for accessing our rows and columns, the as usual way of accessing matrices. Now in this particular, again we have taken +1, means one extra row, one extra column for handling our base case, and here we would be starting from 0, not from 1, because in this particular loop only we are basically whenever both of them are 0, then at that criteria we are filling up our base case with is 0. If either of them is 0 and other one is basically greater than 0, then in that particular criteria we are filling that particular position also as 0, the way I had showed you in that particular table earlier. So that's what we are doing here. Means if here you can see that if one of them is basically 0 or less than 0 and other one is greater than, so what we are choosing, we are basically choosing the other word which is there and the result of the previous one. The result of the previous one would be 0 and the other word which would be there, that would be directly kept into that, and the same goes for this particular condition. And now once the part if both of them are basically greater than 0, right, and in them also if both of them are equal, then we would be directly checking for a diagonal element, and if both of them are not equal, then we will be checking minimum out of them. So this is thing which we would be doing in this also, the way we were doing in the recursive solution and then memoised, and then at the end we will be returning this. And why we are choosing this mn and why not I, j or any other position in that table? The thing is that while filling this particular table, that end position would be that particular answer which is being required. Means the minimum out of all of these selections would be directly stored at the end point, that is at the bottom right position in these particular type of questions, in LCS questions. I mean, the way we are going ahead with the same. So that's why we are choosing for this particular position, because in the coming up questions there would be some questions where the answer is not stored at this position but the answer is stored in the table somewhere else. So when we will be coming up at those solutions, then I'll tell you about the same, that why that is the criteria. But for the LCS solution, most of the solution is stored at the bottom right position, the way it is stored here. So this was all for this particular question. If there's any doubt, you could have comment that down. And yeah, I would like to introduce you about the channel sponsored, means the one who is supporting this particular channel. So that is the Newton School, because as most of the students ask me about the structured course where one-on-one mentorship is there, doubt clearing sessions are there, and a lot of things like these are there. So that's why I would recommend Newton School for the same. And the thing is that one of the best things which I liked about the Newton School is that they don't have any upfront fee. So that's why the thing is that when you will get placement from their course, then after that only you are required to pay their course fee, else you won't be required to pay even a single penny of the fee. So that is a thing which is one of the best I liked about the Newton School. And further, their placement packages are from 5 LPA to 40 LPA. So it's like pretty much good range. So that's why if you want to prefer going ahead with the Newton School, you can find all details in the description. Today we are going to do TP challenge 5th day question, and this question is basically uncrossed line. And this question is like these days we are doing question based on longest common subsequence. So this question is also based on the same pattern only. So you would be amazed to see that how it is similar to longest common subsequence. So stay tuned till the end for the same, and let us start with the question. So here comes the part. You are given two integer arrays nums1 and nums2. We write the integer of nums1 and nums2 in order they are given on separate horizontal lines. Okay. And next thing which is given to us is we may draw connecting lines, a straight line connecting two numbers nums1 and nums2 j such that. So here these conditions only take this question away from the else yes, but at the end when you would be doing about some dry run of the test cases, then you will figure it out that it is about else yes only. So here nums1 of I equals to nums2 of j. This is the condition. Then only we can draw a straight line. And the other condition is the line we draw does not intersect any other connecting non-horizontal line. So here two conditions are given, that two arrays are given to us, and in those various integers are given to us, and we can connect a line from one integer to other if and only if they are same. If they are not same, then we can't draw a line between them. And another thing is that when these two integers we are joining them, and when we are joining other two integers which are similar, then both of them, those lines shouldn't be connected. Means they shouldn't intersect each other while connecting the lines. And then next, note that a connecting line cannot intersect even at the end point, that is, each number can only belong to one connecting line, and then return the maximum number of connecting lines we can draw in this way. So here you can see that 1, 1, it is same, right? So that's why we can draw a straight line to the same. 4, 4 are the same, so we can draw another straight line. But here you can see we can also draw a line between 2 and 2, but there the condition would be violated, this particular condition. The line we draw does not intersect other connecting non-horizontal line. So here 4, 4 was already connected, right? So when we connect 2, 2 also there, so at that moment it will intersect this 4, 4, and just because of that only we can't draw 2, 2, right? So this is a thing which we are required to figure it out here, that how much lines we can draw without intersecting any other connecting lines. So here you can see that and so that's the reason we are just giving this 2 as the answer. So now comes the part that we can draw 2 uncrossed lines as in the diagram. We cannot draw 3 uncrossed lines because the line from this particular 2, 2 would intersect this particular line. That's the thing. So in this next example, let me draw on the board, and there you can see that how it goes on. So here you can see this is that particular example which we were doing, right? So here if we check for the longest common subsequence, how we will be checking? 1, 1 is common, right? So we will take it. 2 and 4 are not common, right? Okay, then let us move in the first one to the 4th, and now we got that both of them are equal, right? So but this is now exhausted, right? So till now we got 2, and here also 2, so and then we are returning 2. So again in this particular we check, here you can see that 5, 1, 2, 5, and then 5, then 1, then 2, right? So these contribute to longest common subsequence. And in the other example, 1, 3, 7, 1, 7, 5, here you can clearly see that 1, 1 are matching, then 3 is nowhere there, then 7 is nowhere there, right? 9 and 2 are nowhere there, but then 1 is basically matching with this one, right? So here you will be returning 2 as the answer. That is, the longest common subsequence for this particular would be 2. So this is the thing which we are required to do in this particular question. You can clearly see from this examples only that we are checking for the common ones who are contributing to the longest subsequence. And here we can clearly see that we are figuring out the longest common subsequence. As in the subsequence, we maintain relative position, although there could be instances when whole string becomes subsequence. So this is the thing which we are doing here. Now comes the next part. Okay, it has just 1 minute. So now the question boils down to LCS. So whenever we are required to do the LCS question, how we proceed with the same. So one more thing which was left in this question was seeking the time constraints, right? So here you can see the constraints are the length of the nums array is basically 500, and each character could go up to 2000. Means basically each integer which is being given to us, at max it can go up to 2000. but we are just comparing them, right? Not adding them up, right? So that's why this particular constraint doesn't matter to us, but this matters to us because this will be contributing towards that time complexity of the solution. So according to this, as it is 10 raised to power 2, we can go ahead with the 10 raised to power 4 also, and even 10 raised to power 6 also we can go. Till then there won't be any TLE, right? So order of n solution would also work, order of n log n solution would also work, and even the if we say that order of n square, that will also work here. So these are the range of the solutions which could work here. So let us first figure out, as we had already figured out that this question is about LCS, right? So what we would be doing now is, we will try to first figure out about the recurrence relation of the same, and then how to memorize it, and then bottom up DP. So let us go ahead with the same, then after that I'll show you the code walkthrough for the same. Okay, so yeah, let's go. So first comes the part about the recursive solution. So for the recursive solution, there are three things which we need to consider. One is base case, other is options, and the third is recurrence relation. But in all these three, first we are required to figure out the options which are given to us. So what options we are having? See, you can clearly see either we can choose this particular one, or we can't choose this particular one, so we will be choosing this particular one. I mean to say that in this whole particular not word, we would be given with string, I guess. Means whatsoever is given to us, string or vector of integer, whatsoever is given to us. So either we will be choosing from this particular nums, right, or we would be choosing from this particular. This is the options which are being given to us, right? Means either we will include it or we will exclude it. This is the thing which we will be doing, right? So two options are there. So according to that only, we would be making our recurrence relation. So in this recurrence relation, how we would be proceeding ahead is, as per the condition, there it was given that if both of them are equal, right? So if both of them are equal, then only we can draw a line between them, right? So if both of them are equal, then we will add 1 to our selection, else we would be checking that whatsoever answer we get maximum, and by maximum we are required to return, because in the question they had stated us that we are required to return the maximum number of connecting lines, right? So that's why we are required to return maximum. So next thing is, that's why if they are equal, then we would be adding 1, because then we can draw a line between them and we will return the function as it is. Else we will return maximum of either choosing the first one or choosing the second one. So this is the thing which we would be doing here. Now comes the next part, that what would be the base case of the solution. So you can see that if a particular here the sizes are unequal, right? So if either of them get exhausted at the first, right? If this second one get exhausted, that is if n becomes less than or equal to 0, right? Then in that criteria we would be returning 0, because after that we won't be having any match. So that's why we will be returning 0 here. So that's why our base case is basically n less than equal to 0 or m less than equal to 0. So we are required to return 0. And how we are required to memorize this particular solution? Because there are two variable paths. One is for the nums1 and other one is for the nums2. So that's why we would be using a 2D data structure for storing our variable parts in the same. And then I'll show you that how we can come up with the same. And one more thing, the time complexity. So the time complexity of the same is order of 2 raised to power n for the first one, m for the second one, n into m, and the space complexity is basically order of n plus m, and here also plus. So this would be the time complexity and space complexity for the recursive solution, and for the memoized part it would be n into m, and for the space complexity that would be also n into m. And now comes the part about the bottom-up solution. So as I earlier told that how we go ahead with the bottom-up solution is that whatever function was here, right, we will directly make into a DP, means basically a table. This would indicate as a vector and this will also indicate as a vector. we'll convert this function into a vector, and 1 would be as it is, and we will be, the way we were assigning in the memoised to a particular vector or any other data structure, like that only we will be assigning this to that. And the test cases would be handled by filling up a table in such a manner, like keeping one extra row, one extra column, where all the zeros would be filled like for this particular base case, and this is how we will be able to transform this particular recursive solution into bottom-up DP. So now comes the next part, that how the bottom-up DP is like. So here the state of the bottom-up DP is basically the T of Mn, and transition is if num1 of n minus 1 equals to nums2 of m minus 1, then dp of nm equals to 1 plus dp of n minus 1 m minus 1. Else dp of nm equals to maximum of either we will be choosing with the first one or we will be choosing with the second one. So this is how our bottom-up solution would be like, and the time complexity would be order of n into m, and the space complexity would be order of n into m. So these are the solution which we can come up with for this particular. Basically, in the interview perspective, they will be asking us from the brute force to the what we say at the most advanced version, means most optimized version. So like this you can come up in the interview for the same. And from interviews I just recall that some of the students were asking about a structured course where they could get one-on-one mentorship or doubt clearance and so on. So you could directly head over to the Newton School, whose description is basically given in the description of this particular video, and even the link to the website is also given there. You could directly head over to that and get all the details which is being there. So this was one of the recommendations from my side for, and so this was all for this particular question. Now comes the part about the code walkthrough. So let me show you about the code, because that is also important. Without that, question is incomplete. So here comes the part for coding, and here this is. So first is this one, which is our recursive solution. So here you can see that in this particular we are basically making a function solve, and in that we are passing nums1 and nums2 and passing the sizes of the both, and then what we are doing is we are directly taking three options, because we are having either we will be skipping both at the same time, or we will be choosing one at a time, or we will be choosing the other at a time, right? So that's why we are having three options. And then here first I have taken about the base case, that is n is less than equal to 0 or m is less than equal to 0, then we will be returning 0, because if either of them get exhausted, right, then in that particular scenario we are required to return 0. And the next part comes up that if both of them are equal, then we will be returning 1 plus solve of nums1, num2, n minus 1, m minus 1. Basically, we have selected because both of them are equal, and then we will be moving ahead with the others. And now comes the next part. My cursor is not moving. Okay. So now comes the next part. Option 1, that either we would be choosing the second one, that is m minus 1, or we would be choosing the first one, that is n minus 1, and then we will be returning maximum out of both. So this is, we are going ahead in our else part, and this was about the recursive solution. Now comes the part about the memoization. So in memoization, we have taken a dp of 501, 501 just because of this thing which is given to us, that is we are having at max 500 length correct elements in a nums1 and nums2, so that's why just taken one extra just for handling up the base case. And let us first start from here. Here we are basically taking our dp and giving it this size and even initializing it all with -1, and then we are passing the same way we were passing in our previous recursive, and here is the same way our base case, and then here is the that if it is not -1, because earlier we had initialized it with -1, right? So if it is not -1, then surely there would be a sub case which is being stored in the same, right? So that's why at that particular moment, if it is not -1, then we will be returning the same. Else we will be going ahead with our solution. We will be checking that if at this particular moment nums of n minus 1 equals to nums of m minus 1, means at this particular moment both are equal, then we will be directly adding 1 and calling that function, and whatsoever result would be, we will be assigning that to this particular dp of n-1 m-1. So that is the case here. Else we will be checking for our options, and then we will be getting the maximum out of option 1 and option 2 and assigning to a dp of n-1 m-1, and at the end we will be returning this particular, that is return dp of n-1 m-1 equals to maximum of option 1, option 2 and option 3. So this is the thing which we would be doing here. And now comes the next part, that is this particular bottom-up dp. So here we are at the starting only taking up this size, and then here this is that 2D vector in which we have initialized with 0, and why we have initialized the 0, so that row 1 and column 1 became 0 only, and further rows would be filled up as per we will be moving ahead. So that's why even if we make whole our dp vector of vector as 0, then also it's fine. So here comes the part for the 2D, not 2D, but nested loops, and here we can check that if both of them are equal, the way we were doing in our recursive and memoised, then we will be assigning to our dp of ij equals to dp of i-1 j-1 plus 1, else we would be checking maximum out of both the cases, and at the end we will be returning a state that is dp of mn. So this was all for this particular question. If you have any doubt, you could comment it down, and if you like the explanation or if you like the whole video, then surely please do like, subscribe. So now we are going to do another question of our DP series, that is max dot product of two subsequences. Basically till now we are doing all the questions of LCS only. So this is also one of the question of LCS, but for the next time I'll make another topic series. So this is the last question for LCS which we are going to do. So let us go through this question. So given two arrays nums1 and nums2, return the maximum dot product between non-empty subsequences of nums1 and nums2 with the same length. So in this question we are required to return maximum dot product from nums1 and nums2, and we will be doing dot product of the same, and then we are going to return the maximum of them. Till now we were doing longest common subsequence, right? So here again maximum thing is there, and here somehow the thing is about the common. So because of that common only, it will be becoming the LCS question, and how that is there I'll show you in the further example. A subsequence of array is a new array form that we already know, and here we know that 2, 3, 5 is, these things we already know. Now let us directly jump towards the constraint. So basically the constraints are in such manner so that n square solution would easily work here, and even the numbers which are being given here. So yeah, each number can go from -1000 to 1000, so that even if we multiply at max 1000 into 1000, so it will be going till 10 raised to power 6. So that's why the range of the numbers is given in this image. So now let us go to this question. So here if we see for doing the dot product, let me show you the example. So for doing dot product, either we can do 2 into 3, or we can do 2 into 0, or we can do 2 into -6, right? Means one time we are fixing the 2 and checking for all the all which are being there in the nums2, and then we can also do other way around, that we are checking for 2 into 3, then 1 into 3, then -2 into 3, and then 5 into 3. Means any way around could be there, right? Means either we could fix the first one, or we could fix the second one, or even this thing also be there, that we are fixing both of them. Basically 2 is also fixed and 3 is also fixed. Then in the next one 1 is also fixed and 0 is also fixed. So like this manner also we can go, right? So somehow here it comes out to be selecting one and non-selecting one. So it's somehow that it becomes a question of inclusion and exclusion, right? So in all that context, now how LCS comes into the picture. So here when we are either including this or including that, and there is one more thing which is being given to us, that we could also check that whatsoever was previously stored, that also, and what is the next one which would be stored, that is also being there. Then also we can get a direct dot product, which is the maximum. And in other example, if we see here, they are just taking for the one only, that is one from the nums1 and one from the nums2, right? So that's why here directly we are checking for nums1 of I and nums2 of j. That's the thing which we are doing here. So these are also some of the examples, right? Now let us go ahead that how we are required to check for that how we are going to even come up with the recursive solution or DP solution. This is a DP solution, that's for sure, because from the first example itself we can see that we are adding up from the previous one also, and even as per the question that we are required to figure out with the maximum dot product, so we are required to try out all the possible combinations, and when it comes the part for the possible combination, so it simply depicts that it is a recursive solution. And as per the as per the constraints given, so their recursive solution won't work. So surely we would be required to memoise it, and when the memoization comes into picture, so surely there would be a bottom DP also. So that's how this question becomes the question of DP. But surely this question is of inclusion and exclusion, that we can clearly see. How it is a question of LCS or not, that we will come afterwards, means when I would be coding, then you could clearly see that how it is. And even from the fact that we are including or excluding, that also depicts that it is a question of LCS, because we are figuring out that what is common among them, means common for the nums1 and nums2 which is there, that we are already figuring out here. So although not directly as LCS, but still the pattern which we are following here, from we are selecting from nums1 or not, nums2 or not, that simply reflects that it is somehow following the path of LCS. That's the thing here. Although in LCS what we were doing was, we were just checking that if nums of 1 or nums of 2 are they equal, then we were doing some operations, as if they are not, then we were doing some operations. But in this question, we are not doing if-else conditions like that, but we are directly moving ahead, selecting from the nums1, selecting from the nums2, basically the sub portion of the LCS, that is inclusion and exclusion question, that is this question. And that is how only some portion is similar to LCS, not the complete portion. That's the scenario here. Now let me show you that how we can come up with the recursive solution for the same. So for recursion, what the things we are required with? We are required with the recurrence relation, and before that we are required with options, right? And after that we will check that what base case we would be selecting. So for that thing, let me show you that how we can do that. You have already seen that what sort of examples could be there. Now let us come to the coding approach of this particular. Let me show you. So here you can check that nums1 and num2 is there, right? So options what we are having, either we can select from nums1, or we can select for nums2, or we can select from both of them, as I had shown you in the example, right? In example 1 and example 2. So like that only we are having options that we will be selecting, and even we are required with the maximum dot product, right? So that's why I am doing with the maximum, that whatsoever option was stored previously is that maximum, or the new which we are calculating, that is maximum, that is nums of I minus 1 into nums of 2 j minus 1 plus recursion of I minus 1 j minus 1. So basically we would be multiplying the present nums1 and nums2 numbers which would be there, and then adding up the recursive call for the previous one which would be coming up. That is what else which we can exactly figure out that is it basically giving us the maximum output or not. So that's the thing which we would be doing here. Now next option is there. We will be selecting that was the option 2 which was earlier stored, is that maximum, or the one which now we would be going ahead with this particular recursive call, that is not selecting the first one but selecting the second one from the nums2. So that's why we are doing this. And third option is that either the option 3 itself is the maximum, or the recursive call which will return us the answer after selecting from the nums1 and not selecting from the nums2. So this is the thing. So here the things are that either both of them are variable. So either first one is the variable, that is first one we are moving ahead. So here option 2 is there, but here also one condition is that if the I is basically greater than 1 or not, then only we will be going ahead. And here also we are having, because j minus 1 is there, so it will also only go in that manner when j is basically greater than 1. So that's why we are taking second variable part, that is this one. Now these were the options, right? And these options are basically also somehow reflecting towards our recurrence relation itself, because our recurrence relation would be somehow like this only, and then at the end we would be returning maximum out of all these three options, because at the end we require the maximum dot product, right? So maximum dot product would be returned out of these three only. And then our base case is basically when I equal to 0 or j equal to 0, then we would be returning 0, because as multiplication with 0 is always 0, right? So that's the reason in this base case we are doing like this. So this is how our recursive solution would be. And then comes the part for memoization. So memoizing this particular, we can clearly see that there are two variable parts, I and j, right? So that's why we would be going ahead with a 2D vector or 2D array, means any 2D data structure we would be going ahead with, and according to that only we would be memoizing this particular solution. So after this, now comes the part for the bottom up. So for bottom up, our state would be tp of n into m, that is the last one which would be there, that would be reflecting as our answer, and the transition would be somehow same the way we were doing in our recursive. That is the first part which was there, that we would be choosing the first from the nums1, first from the nums2, that we would be choosing. And as this would be a loop, so in that loop only we would be going ahead with all the selections of by basically making both of these as the variable. And now comes the part for nums_i minus 1 into nums2j minus 1. So for this particular, we are basically choosing this one also and then adding up what was stored in the previous answer. So that's the thing which we are doing here. Or we will be checking that when making the first one only as the variable and keeping the second nums2 as the fixed part, so then at that moment are we getting the maximum answer or not? Or if we are keeping the nums2 as the variable part and nums1 as the fixed part, then at that moment are we getting as an answer or not? So this is how we are checking for that out of all these in which we are getting the maximum. So this was about the approach of doing this question. Now let's directly head over to the coding part of this question. So here it is. So first let me show you how recursive solution is like. So basically in this recursive solution, how we would be going ahead is that here we are not doing in the main public function which is there, we are just calling a recursive function where we are passing with the nums1, nums2 input vectors which were there with their size, means size of both of them. And then here in this recursive solution what we are doing, we are taking three options, basically all three options which I have shown you in that recursive solution, and in that the base case is this one, that either I equal to 0 or j equal to 0 we would be returning 0. Then in the case of option 1, we are simply checking the maximum of option 1 or nums of I minus 1 into nums of I j minus 1 plus what were there to be given to us from the previous recursive call. And then in the option 2, we are first checking that if j is greater than 1. If it is, then we are checking for what is being there in the option 2 and what is being returned by this recursive call. Out of them, whichever is the maximum, we will be storing in option 2. And then for the option 3, we are checking I is greater than 1, then only we are checking ahead. And at the end, we are returning with the maximum of all of them. So this is how we would be going ahead with the recursive solution. Now comes the part of memoizing the same. So for memoization, we are taking a 2D vector. So for that 2D vector, the first thing is that we would be resizing it. So this is how we are resizing it and taking the size +1, and +1 is for our base case, and we are initializing with int min. That would be acting as our flag, that if it is not int min, then surely there is some some answer stored. So whole solution is as it is, the way it is in recursion. Only part which is changed is this memo part, that if it is not equals to int min, that means that surely there is something stored, so we will be returning that. Else we would be storing in memo of ij, and same goes for this option and same goes for this option, and at the end we would be returning the memo of ij, just because of the fact, because memo of ij itself would be storing the maximum out of all three options. Because earlier what we were doing was, we were directly having the option 1 and the option 2 and the option 3, right? And we were figuring out the maximum out of option 1 and what is being stored in the present one. But now we are figuring out that all in this single lines with the memos. So that's why the maximum answer would be itself stored in this particular. Now comes the part for the bottom-up solution. So for bottom-up solution, here just figure out with this particular, so that there is no error for that memory and so on. You can clearly see here the ranges which are being there. So according to that only, here the ranges is like 10 raised to power 6. At max it could go, right? So that's why we have taken the infinity as 10 raised to power 7, just for just one step ahead of the 10 raised to power 6. And then what we are doing is, we are just taking the size, and then here we are, earlier we were initializing with the minus infinity only, right, in that memoization part. So here also we are initializing with minus infinity, just for acting it as flag rather than choosing 0 or -1. And then what we are doing next is, here we are starting from the start. Earlier we were starting from the back side, right? But here we are starting from the start, and here also even we are starting from the start, still we are starting from I equals to 1 and j equals to 1, so that here we can figure out with these parts. So here the thing is, in our nums array itself, whatever would be stored at I -1 and j -1, that would be written here, these multiplication of both of them, and it will be also figuring out with these things, that adding up into the minus infinity or giving with the minus infinity here or minus infinity here, whichever is the greater of all of these, that would be basically returned, and at the end the answer would be returned as this. So this was what for this particular question. And now comes the part for the time complexity and the space complexity. So in recursion, you can clearly see that how many options we are having. So basically we are having here with 3 options, right? So that's why the time complexity here would clearly become 3 raised to power n plus 1. But again the thing is that we are choosing from either nums1 or nums2. That is, either we are including or we are excluding. So that's why choices are among the 2 things only. So that's why rather than 3 raised to power n plus 1, it would be 2 raised to power n plus 1. So that's why the time complexity for the same would be order of basically power of 2 raised to power 2 comma n plus 1 n plus n, and the space complexity would be order of n plus n. So this was for the recursion. It is not moving. Okay. It's not moving because of this. So this was for recursion. Now comes the part for the memoization. So for memoization part, the time complexity is basically order of n into m. That is because of the matrix which we are taking, and the means the loops would which would be there, that would be in that manner, and the space complexity would be order of n into m. That is again because of the matrix which we are taking. And the same goes for the DP question also. So this was all for this particular question. I hope you like the explanation. If you like it, then do like and subscribe to my channel, and also do share it if it added value to you. And one last thing is there, that this channel is basically supported by Newton School. And the thing is that a lot of students ask me about if there is some structured course where live doubt solving sessions are there, one-on-one interaction is there, one-on-one mentorship sessions are there. So I would recommend for the same for Newton School. And one of the best part about the courses of Newton School is that there is no upfront fee. You are required to pay the fee after you have done with the course and you are being placed. And their placement starts from the 5 LPA packages to 40 LPA packets. So that's why you could easily get placed at max of 40 LPA. And after that, after being placed, then only you would be paying for the fees of the course, else you won't be paying fees for the course. So this was all.